Resolution, accuracy, repeatability, and precision are critical requirements of motion systems. They fundamentally impact system complexity, cost, and development time. Understanding these terms will help you refine and optimize your instrument requirements. Let's use a simple illustration. If you were throwing darts at a dartboard aiming for a bullseye, accuracy would be how close to the bullseye your dart landed, repeatability would be your grouping if you threw multiple darts, and resolution would be the skill of the thrower to adjust their aim and incrementally place darts vertically or laterally on the board. When we consider these terms with respect to M3 motion modules, we first need to understand the elements involved. A piezoelectric motor produces movement in the stage, an internal position encoder measures the position of the stage, a drive circuit energizes the motor, and a digital controller reads the position from the encoder and commands the motor to move. Position resolution is the smallest incremental movement that can be generated by the M3 modules. There are two kinds of resolution. Open loop resolution is the smallest movement the motor can make in response to an input signal. For most M3 modules, this is tens to hundreds of nanometers. Closed loop resolution is the smallest movement that the controller can make, using its closed loop control algorithm. In practice, it is the minimum movement that the position encoder can detect. For M3 modules, this is typically 500 nanometers. In closed loop operation, accuracy is the variance between the commanded position and the actual position. Position repeatability, often called precision, describes how well the motion system returns to a consistent position in response to the same command. Repeatability can be bidirectional or unidirectional. Unidirectional positioning provides better repeatability at the cost of extra moves. Let's look closer. Here an M3 module moves a lens to a series of target points, both in forward and reverse directions over its full travel range. We repeat the process twice and look at the difference. The difference between curves moving in the same direction is unidirectional repeatability. The difference between curves moving in opposite directions is bidirectional repeatability. A system designer needs to know when the higher repeatability is worth the extra moves. M3 motion modules have high resolution and repeatability for positioning of optics, probes, samples, and more in precision instruments. Contact us and let's discuss your performance requirements.